Alright, welcome to the video on 10.2 arithmetic sequences. So an arithmetic sequence is a special kind of sequence where each time we basically add or subtract the same number over and over again. Whatever we're adding or subtracting is called the common difference. So that's the common difference. The graph of an arithmetic sequence forms a discrete set of points lying in a straight line. Thus, it is a linear function whose domain is a set of positive integers. And the first term of an arithmetic sequence, A1, each term after is obtained by adding D. So what you can think of if we write a recursion formula for this is I take the previous term and I add D to it, where D is the common difference. So let's just see this in an example. So it's really, arithmetic sequences are pretty easy to deal with. So if I look at this, I've got A1 is 100, and my common difference is negative 30. So I take 100, I subtract 30 to get to my next term. Now subtract 30, subtract 30, subtract 30, subtract 30, and so on. And those are my first 6 terms. So I think you'll find in 10.1 through 10.3, there's no individual concept that's all that bad. It's just kind of deciding what to use where is kind of what you're going to have to watch out for. All right, so let's just consider an arithmetic sequence. First term is A1, the common difference is D. Fill in the table below. So our first term is just going to be A1. Then we're going to add D to that. If I add another D, it's going to be plus 2D. So this is going to be A1 plus 3D. We're going to add another one. It's going to be A1 plus 4D, A1 plus 5D. And so what do you think our formula is? Just take a second and think about what that formula would be. For the nth term, it's going to be A1 plus n minus 1 times D, right? For the 6th term, we added 5. For the 5th term, we added 4. For the 4th term, we added 3D, 2D, 1D, etc. So we're adding 1 less than the n that we're at. So, and I guess we can fill these in. So we just basically came up with what the general term of an arithmetic sequence is. So if I want to find like the 50th term, I don't have to go through and subtract that many times. I can just use my formula where an equals a1 plus n minus 1 times d. So that's kind of the first of the formulas that you're going to want to know. So find the 9th term of the arithmetic sequence whose first term is 6 and the common difference is negative 5. So an is equal to 6 minus, well, actually I'll write it in the normal form, plus n minus 1 times negative 5. You could have the minus sign there in front, but I'll try and follow the standard form there. So I get 6, the 9th term is going to be plus 8, because 9 minus 1 gets me 8, times negative 5. I get negative 34 as my answer. And if you wanted to, again, you could see we'd have 6, comma 1, comma negative 4, comma negative 9, comma negative 14, comma negative 19, negative 24, negative 29, negative 34. If you count, this is A1, 2, 3, 4, 5, 6, 7, 8, 9. We see that that's A9. But we can do it a lot quicker if we do it that way. Write the formula for the general term of the arithmetic sequence. So looking at this, notice A1 is just the first term, so that's negative 4. And how do I get from negative 4 to 2 and 2 to 8 and 8 to 14? Well, I'm going to add 6. My common difference is equal to 6. So an equals negative 4 plus n minus 1 times 6. And I realize you could simplify this down. You could say, well, that's negative 4 plus 6n minus 6 equals negative 10 plus 6n. I actually kind of like to leave it like this. It's just a little bit more, it's right from here we can see what the first term is and what the common difference is. Here we got to do a little rigmarole to figure out what the first term is. We got to do negative 10 plus 6. It's just, they jump right out at you when you leave it in the standard form. So I encourage you to not do the algebra to simplify that. All right, so using an arithmetic sequence to model changes in the U.S. population. So a lot of times we'll just model things year by year, right? We won't say, we don't really care what the population was in October versus March when we're talking about a census. I mean, we do a census every 10 years. So the data show that in 2010, 16% of the U.S. population was Latino. On average, this is projected to increase by approximately 0.35% per year. Write a formula for the nth term of the arithmetic sequence that describes the percentage of the U.S. population that will be Latino n years after 2009. Okay, so first things first, make sure you recognize a couple things. So if we have if we call our formula AN, A1 will represent 2010, right? Because when n is 1, that's 1 year after 2009. So A1 represents 2010. Another thing to recognize is that we want to describe the percentage. So we're not going to convert 16% to 0.16 and that to 0.0035. We're going to leave them as is. So A1 is 2010, which is 16%. Our common difference is going to be 0.35%. So AN is equal to 16% plus n minus 1 times 0.35%. So what percentage of the U.S. population is projected to be Latino in 2030? So in that case, again, keep in mind 1 is 2010. So if we go 20 years after that, it's going to be A sub 21. So I get 16% plus 21 minus 1 times 0.35%. So basically I get 20 times 0.35, so 2 times 0.35 is 0.7. Add a 0, 7%, I get 23%. All right, so now we're going to talk about the sum. So this is kind of, basically there's two types of things that we're going to be looking at. Sequences, which we've been talking about this whole video, and then series, which typically when we're talking about series, they'll be infinite. But basically what we look at is the sum of the first n terms of an arithmetic sequence. So like if I look at this, S1 would be equal to A1. S2 would equal A1 plus A2. S3 would equal A1 plus A2 plus A3. So these, this capital S sum generally means the sum of the first n terms. All right, so let's come up with what this formula would be. So first off, hopefully you'll agree with me that Sn is equal to A1 plus A1 plus D, that's our second term, plus A1 plus 2D, that's our third term, plus dot, 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 dot. And then at the end here, our last term is just basically AN. We'll just call it that. It could be A1 plus n minus 1 times D, whichever way you want to represent it. But for the purposes of this, let's go ahead and write it this way. Now, hopefully you'll agree with me that I could write this in the opposite order. So I could write this as AN, and then so that's the last term. The second to last term, instead of adding D each time, we're going to subtract D each time. So let's subtract D, and it's going to be AN minus 2D plus dot, 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 plus A1. Now notice, if we add these two together, you notice on the left side I get 2Sn is equal to A1 plus AN. And now what happens when I add the second circle here? I get A1 plus AN, and I get D minus D. So I get another A1 plus AN. And what do you know? I get another one, A1 plus AN. And that's going to happen for all of them. And then at the end, I end up with another A1 plus AN. So notice, how many of these do I have? Well, there are n terms in the sequence. So if I add those all up, I get 2Sn is equal to n times A1 plus AN. Again, how do I get that? It's because I have each of these is the same thing, and I have n of them, right? First, second, third, and then all the way up through n. And if I add up n of the same thing, it's the same as multiplication. And now all I need to do for my final step here is divide by 2. And there's my formula. So let's go ahead and write that up there. All right, so find the sum of the first 15 terms of the arithmetic sequence. So notice again on this one, A1 is equal to 3. D is also equal to 3. So we want to know A15 because we're looking at the 15. So A15 equals 3 plus 14 times 3 equals 45. So the sum of the first 15 terms is going to equal, again, 15 over 2, just using the formula from up above. A1 is 3 plus A15, which is 45. So that gets me 48 divided by 2 is 24 times 15 gets me 360. A lot better than having to add them all up. Hopefully you'll agree with me on that. So looking at this, use the formula to find the following sum. So again, I did show you on the last video how to use your calculator for this, but we can do this again. I can do it faster than you could, pull out your calculator and plug it all in. So if we want to look at it, again, A1 is going to equal, plug in 1, I get 6 times 1 minus 11. I get negative 5. Now notice each time I'm going to be adding 6, so D is equal to 6. So we're going to need to find what A30 is. That's equal to negative 5 plus 29, and minus 1, right, times 6. So 30 times 6 is 180, so I get 174. Minus 5 gets me 169. Okay, so maybe you could probably pull out your calculator and do it faster than me, but to find out the sum, then that's going to equal n over 2. So n over 2 is 30 over 2. It's going to end up being 15. And then it's going to be A1, so negative 5, plus A30, which is 169. So I get 15 times 164, which should be 246. So 2460, I believe. So we can double check, make sure I got my calculation correct. So I could go to math summation, and I can go from 1 to 30. I guess I'm still in parametric from last chapter. 1 to 30 of 6t minus 11. And there you go, 2460. So, but you can kind of see it's really not that bad to do by hand, or even with with a simple calculator. All right, so last question, last example. Your grandmother has assets of $700,000. One option that she is considering involves an adult residential community for a 10-year period beginning in 2018. The model A sub n equals 1800n plus 64,130 describes the yearly adult residential community costs n years after 2017. Does your grandmother have enough to pay for this facility? So again, so we need a 10-year. We need to basically figure out if she pays this every year, what will it be above 700,000 or not? All right, so if again it says n years after 2017, so she's going to start at n equals 1. She's going to start in 2018. So again, if we look at it, A1 is going to equal 1800 plus 64,130. So 65,930, right? All right, so that's A1. We need to figure out what's the cost going to be at at her 10th year. So that's going to be A10, and that's going to be 1800 or 18,000 this time, because again multiply times 10 plus 64,130. equals, and in this case, 72, 82, 130. So our sum of those 10 years is going to equal 10 over 2, right? N is 10 divided by 2. A1 plus A10. So I end up basically with 5 times 65, 930 plus 82, 130. 740,000, so no, she does not.